Welcome back to Technology and Programming and Mathematics. Here we are going to talk about using the math library. So let me go ahead and open a new REPL right here. So we'll do a Python, and I'll just call this one using square roots. Okay. So that's done. Okay, so over here, I'm going to try to compute some square roots. Make that nice and big so we can all see what's going on. So let's just kind of take a guess and try this, square root 36. Okay, you'll see nothing happens there. It actually gives me an error. That's because the square root function is not built into the main Python library. Here's what you need to do. You need to give Python access to a special math function library by typing import math, and then if you do math.square root, then it'll actually compute the answer. Okay, so import math gives us some access to new types of functions that we otherwise would not have access to. So in our program here, in our code, yoink, we'll do that. We'll do import math, and we'll comment that gives access to new functions. Okay, so here's what we'll do. I want the user to input a value, and we will have the program decide whether that number is a perfect square. Okay, so getting the user to input a number, that's easy enough. We'll just call it num equals, and let's allow the user to input a floating point, so we'll do a float input, give me a number. Okay. Say, all right, give me a number. Well, let me reset that. Is that kind of seeable? Yeah, we can kind of see that. Okay, so this will prompt the user for a number. And here's what we want to do. We want to see if this number is a perfect square. So what I'm going to do is I'm going to have the computer take the square root. And if we get an integer, then what we started with was a perfect square. So how about this? What if I did root equals math.sqrt num? Okay, so that returns the square root of x. So remember, these equal signs are an assignment operator. So we're going to do this operation to the variable number and store that in the place root. I'm just going to do a little test. Print the square root of blank is, okay. I'm going to do something a little bit different than what I had done before. Let me see here, 0.2f. Format num root. Okay. In a previous video, we had made use of this dot format command at the end, but if you go back and look, I did not put these numbers in here. I just put these braces and it was blank. This is kind of useful if you have multiple things and you might be switching back and forth. So 0 refers to the first thing, 1 refers to the second thing. This is a formatting command. Okay, so it's going to format with 2 decimal places. So give me a number. Oh, I don't know, something that's not a square root, 39. Okay, so the square root of 39 is 6.24. All right, now I want you to look at what happens if I didn't put that in there. Okay, let's run it again, and let me better make this big for us all to see. Okay, so it's saying give me a number, 39. Okay, the square root of 39 is 6.244, blah, 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 blah. It's giving us all those decimal digits. Okay, so a handy thing to get some nicer formatting is, let's say you want to round your printing to 2 decimal places, 0.2f, okay? So 2 decimal places on your floating point number. And we'll run the program again and we'll see the difference. So if we did that 39 again, the square root of 39 is 6.24. If I made this a 5, the square root of 39 is 6.2500. It'll round to 5 decimal places. Kind of unusual that it's truncating it like that. Okay. So you get the idea. Okay. So now let me change this up a little bit and discuss the advantages of having these numbers in here rather than just having the blanks that we had before. Okay. So the square root of 39 is blank. Let me go back inside my string, okay, and if, so let me do something like this. We'll say since, and now I'll go back to 0 again. No, let's say it like this. If the square root of, and now back to 0, were a whole number, we would call 0 a perfect square. All right. So let me run the program one more time. So I added a bunch of stuff, and notice I referred to 0 several times. So let's run this program again. Let's go 75. Okay, make it nice and big so we can see that right-hand window. Okay, so give me a number 75. The square root of 75 is that. If the square root of 75 were a whole number, we would call 75 a perfect square. Okay, so that's the advantage of using these number kind of designators in those placeholders. You can kind of call back to things, and these numbers are referring to the position in this list. Okay, 0 is the first thing, so it's kind of like how many steps you have to move over. You want to get to this first thing in your list, you don't have to move over at all. If you want here, then you have to move over 1 spot. If we had a third thing in the list, then that would be in position 2. So the counting starts from 0. Okay, so you might want to make a note of that. You have a way to kind of refer back and forth to things in a list, and also this rounding trick. If we want to round to 2 decimal places, then we can put a colon saying, okay, we're talking about the thing in position 1, and these are the options we want. We want to round 2 decimal places for our floating point. Okay, so what we were doing was wanting to check if the number that the user put in was a perfect square. Okay, so we're going to need to do a test. So here's the test I'm going to try. If root equals int root, then I think I'm going to change my print statement here. And here's what I'll do. We'll say we can see 0 is a perfect square because the square root of 0 is 1, a whole number. Okay. So if that statement is true, if this condition is true, if the value of root is equal to the integer value of root, then we'll have it print this statement. And we'll do an else print sorry is actually okay, I'm going to cheat. I'm going to copy this and just modify it a little bit. Okay, so copy that. Okay, so we can see that blank is not a perfect square because the square root of blank is not a whole number. Okay, let's run the program and see what happens. Give me a number. Let's do a perfect square and test it. 49. So we know that's a perfect square. Okay, great. We can see 49 is a perfect square because the square root of 49 is 7, a whole number. Nice and big. Okay. Okay, let's run it again. And we'll do something that isn't a perfect square. 70. Okay, we can see 70 is not a perfect square because the square root of 70 is blank, a not whole number. Okay, that's my grammar was not great there. Not a whole number. And remember, we can do some formatting there. Let's go 0.3f just to kind of make it a little bit nicer. So give me a number, 64. We can see 64 is a perfect square because the square root of 64 is 8, a whole number. Give me a number, 60. We can see 60 is not a perfect square because the square root of 60 is 7.746, not a whole number. Okay. So import math gives you access to additional functions, and we've also kind of refined our understanding of the format command by using these numbers inside the braces, indicating the position of what we're doing in this list.